Hi, today we're going to be looking at the antiderivative of e to the x. So before we do that though, let's recall what we learned about the derivative of e to the x. Remember, the derivative of e to the x is itself. So therefore, if we were to take the antiderivative of e to the x, we have to ask ourselves a question. What function's derivative is e to the x? And that's pretty easy. It's going to be e to the x. Don't forget though, we always have to add a little constant there. So when we're taking the derivative of e to the x, these are very easy to do. You're always going to get the exponential back. Now in most cases though, we got to be careful. We will have to do a U-Substitution. For example, let's try to find the antiderivative of e to the 2x dx. Now, we know it's going to be the differential back, the exponential back, e to the 2x. But we have this 2x up here. So therefore we have a U-Substitution. And if we let u equal 2x, du equals 2 dx, or dx equals du over 2. And if I rewrite that, we're going to get e to the u, du, and I'm going to take out the 1/2. Now when we take the antiderivative, very easy. The antiderivative of e to the u, according to our new rule, is e to the u plus c1. And we get a final answer. 1/2 e, replace your u back in, 2x plus c1. And there's your antiderivative right there. Very easy to work with. So let's try a slightly harder one. What if we did something like this? 2x times e to the x squared dx. Now later on we'll be learning about integration by parts, and you're going to want to do this using an integration by parts, and it's much harder. I don't encourage you to do that. So sorry about the focusing issues. So if we take a look here real quick, we're going to have a U-Substitution, and there's our u. U equals x squared, du is 2x dx, and dx equals du over 2x. So if I plug that back in, we're going to get 2x e to the u dx over 2x. And notice those 2x's will cancel, which is what you want. The whole purpose of U-Substitution, remember, is to either replace your x's with u or to eliminate all the other x's. And we've done both here. We replaced the x squared with u, and we eliminated the 2x. So we're having extreme technical difficulties here today. So whenever we write this, we get e to the u. Oh, that should be a u there. Sorry about that. Du, and the antiderivative, of course, is e to the u plus c1. Or if we want to rewrite that, e to the x squared plus c1. And there's our antiderivative. And there's the lunch bell. All right. So we can even make these a little bit harder. Let's try number 3 here real quickly. Now, number 3, let's try this. E to the 1 over x squared dx. Same idea. There's our u. Don't even try to think about it. Most likely when you do with these, it's going to be the power. U equals 1 over x. My du, we've done this derivative so many times, it's negative 1 over x squared. Dx equals negative x squared du. And I'm going to replace that now. We get e to the u over x squared times negative x squared du. The x squareds cancel, and we get negative, back out to negative, e to the u du. Or this stuff stinks, you can say eu. We get negative e. Now if you don't want to, you don't have to go to the u here. You can go straight to your replacement, 1 over x plus c1. And there's our antiderivative. Very easy to do. Matter of fact, so let's take a look at some slightly more complicated ones here. Number 4, for instance, is kind of a nice one. But this time let's add a domain to it. E to the x over 1 plus e to the x dx. So a lot of times people say, oh no, what am I going to use? How do I solve this one? Well, we can split the fraction up, unfortunately, here. But what I can do is I recognize the bottom. If I take the derivative of the bottom, I get e to the x. That's the same as my top. So let's see what happens. So I'm going to try. If worst comes to worst, you take the wrong u, you start over. We get e to the x dx, so my dx equals du over e to the x. Now, if I replace it, now remember, I'm using U-Substitution, so I'm not going to write my domains just yet. I get e to the x over u. Oh, look, my x is over u. Okay, moving on. Du over e to the x. Cancel out the x's, and I'm left with 1 over u du. Now I'm going to replace my domain. When x was 0, u became 1 plus e to the 0, which is just 2. Be careful, that's just 1 there. Don't make that mistake. When x is 1, u equals 1 plus e to the 1, which is 1 plus e. So we can go from 2 to 1 plus e. Now we're ready for the antiderivative. Well, this is our 1 over u. This is our natural log rule. 2 to 1 plus e. We get the natural log of u. And when I integrate this using my FTC, f of 1 plus e minus f of 2, we get the natural log of 1 plus e minus the natural log of 2. And it is okay to leave your answer like this, but I could also write as the natural log of 1 plus e over 2. And it's okay to write your answer like this as well. Cool thing about logs, you can always rewrite them somehow. Alright, number 5. So let's take a look at, number 5 here. Let's see what happens if we try to add a trig function to this. Let's do the antiderivative of the sine of x e to the cosine of x dx. And let's try to integrate this from 0, to pi. Keep it simple for us. So there's our u. So u equals cosine of x. Du is negative sine of x dx. Dx equals du over negative sine of x. So if I replace that now, we're going to get, I'm not going to replace my domain just yet, sine of x e to the u du over negative sine of x. Cancel, cancel, which is what I wanted them to do. And I get negative e to the u du. And at this point, I'm going to change my domain. When x equals 0, u equals the cosine of 0, which is 1. When x equals pi, u equals the cosine of pi, be careful, which is negative 1. So we'll go from 1 to negative 1. And you can, now it's really kind of cool, I could flip this, I can use my rule to flip this and go from negative 1 to 1, and that's going to make that a positive e to the u du. Just one of our properties from earlier. So therefore, when I integrate this, I can go from negative 1 to 1, e to the u, which becomes just e minus 1 over e. Because remember, that's e to the first minus e to the negative 1. And there's your answer. That's a lot of e's. Alright, so I'm going to go and stop this video here, but if you want to, you can go ahead and proceed to my next video, and I'll take a look at how we can use this to solve differentials and such. Okay, so I'll see you guys then. Bye.